The first I'll illustrate by talking about a project that we've got underway right now in Spain. This is a project we're working on with the European Space Agency, which plans on deploying a satellite called Gaia at the end of next year. The goal for this satellite is to map over 1 billion celestial objects, 1 billion sources of light, to record information about those continually, and every few weeks download that data to an Earth station and have that data be made available to scientists working throughout Europe. So every few weeks you have a challenge of inserting into a database data for 1 billion different celestial objects. In the course of those few weeks, there will be about 100 observations for each of those objects. And each of those observations is a structured set of data with position, apparent velocity, luminosity, other such characteristics. And the goal is to be able to absorb 60 terabytes of data as quickly as possible and make it available to the hundreds of researchers that are trying to use it. Some of you may be familiar with a problem that this sounds like that we tackled a few years ago for financial services, where we built the ability in C++ to do very high insertion rates of objects into cache and then provide SQL queries against those data. In many ways this is similar, except now what we're doing is we're using Java to insert those objects. And we're not just achieving high object insertion rates, but we're actually able to allow people to run sophisticated SQL queries against the data at the same time. When we first became engaged in this project, it was the European Space Agency was projecting it would take them more than a week to upload this data each time. What we're able to do, using our new Java object insert, is to trim that time down. Right now we're about 3 hours, because we can do 70,000 object inserts per second sustained on each core that we have. And we can use our ECP technology to scale that out across multiple servers. And we can allow people to run SQL queries against that data, because we're not just inserting this data as blobs, we're inserting this as structured data with index updates taking place and SQL queries running against the data. Another really important feature that I want to discuss is what we call database mirroring. This is a new technology that we have invented that gives you high availability at much lower costs than any other solution available today. Mirroring uses change records, propagates them to redundant servers. The key thing, though, is that those servers only need to be connected via TCP. You don't need to have a sophisticated storage area network and complex control software to manage the failover. So you can have cheaper storage because you're using redundant storage rather than sophisticated controlled storage. And you eliminate the need for cluster software to manage your environment. Both of those offer significant cost savings. We've integrated mirror failover with our ECP technology, and we've also provided our own virtual IP technology so that ODBC connections, JDBC connections, any of the cache bindings can survive such failover from one mirror member to another. We think that mirroring provides a really interesting new alternative for high availability, and we think that many people will elect to use this over more sophisticated and much more expensive solutions. Final technology element I'd like to mention in the cache context is the identity management software that we have been creating over the last few years. The general challenge here is to find records that really represent duplicates. For example, if the information is about people and there's been a misspelling in entering someone's name, or there's been a transposition of digits in entering an address, you can have multiple entries for the same individual in the same database, or between different databases where different information may be stored about the same individual. It's obviously important for us to be able to identify which of those records correspond to the same person and fold them together. And our identity management software provides a way of doing that. At the lowest level, the indexing capabilities and the matching rules are available as part of Cache, whereas if you go higher up in the stack and you use Ensemble, now you have additional capabilities to use connectivity to get external sources. Our identity management technology is fully SQL enabled, and it adheres to the same principles of frugal use of resources and therefore provides huge scalability, as is typical of all Cache technologies. These and many other features are part of Cache 2010.2. The identity management has been evolving over the last few releases, but mirroring and the high-performance Java inserts are both new with Cache 2010.2. We have been releasing new versions of Cache and Ensemble about every 8 months for the last few years. So over the last year and a half, we've actually introduced 2 new versions of Cache, and we have a new one in field test right now. If you're interested in anything that I've spoken about, please see us so you get access to Cache 2010.2 and experiment with it now. Moving now to Ensemble. All of you know Ensemble as the product we've built on top of Cache, so it's got an embedded, persistent object database in it, but it provides for workflow capabilities, it provides for connectivity options, it provides for business process management, and allows a much broader scope of applications to be built using the same tools.